Hey, today we're going to talk about 7.1, Introduction to Air Pollution. So take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. Alright, so this video is, this topic is like an overview of a lot of the air pollutants that we're going to be discussing. Just basic definition, it is the introduction of chemicals, particulate matter, or microorganisms into the atmosphere at concentrations that are high enough to harm plants, animals, and materials such as buildings, or to alter an ecosystem. Okay, so it's kind of an all-encompassing definition. But the Clean Air Act is the major piece of legislation that addressed this. It authorized the EPA, the Environmental Protection Agency, to set air quality standards. And that doesn't mean that we're going to get rid of all of the pollutants, but we're going to figure out levels at which they are not harmful or not as harmful to humans or the environment. So through the Clean Air Act, they identified 6 criteria air pollutants. And criteria just means like these are the 6 that are the 6 bad ones, and this list has been kind of modified to incorporate a few more, but these are the original 6 that were addressed in the Clean Air Act of 1970. So I have this nice little acronym. Since it's air pollutants, you use a nose clip. If you can remember nose clip without the I, these are the criteria air pollutants. You do have to know the 6 criteria air pollutants. It is part of the requirements for multiple choice or free response questions. So these 6 criteria air pollutants, again, have multiple sources. This is just another cute little image that I've created, but they're identified as a threat to the human and environmental health. So breaking it down, first one, nitrogen oxide. So nitrogen oxides, it's written as NOx, but it includes nitrogen oxide and nitrogen dioxide. And nitrogen oxide, okay, so the first one we're starting with is nitrogen oxides, and that's NO and NO2. NO is actually nitric oxide, and NO2 is nitrogen dioxide. Both of these are formed, first you'll form nitric oxide, then you'll form nitrogen dioxide. And this is just a process that happens in the environment, and we have natural and anthropogenic sources. So naturally we can have anything that's basically adjusting the nitrogen cycle is a natural way. These do occur naturally. However, we are adding nitrogen oxides at a much higher rate because of our activities. So one way abiotically you can add a form of abiotic fixation is through lightning strikes. Through forest fires you can add nitrogen, and also through the activities of soil microbes. So the microorganisms that are living in the soil are also adding nitrogen, and adding parts of nitrogen to a different part of the nitrogen cycle will overall impact the amount of nitrogen oxides we have. However, naturally speaking, the different organisms and this cycle kind of works itself out to keep the levels relatively constant. It's when we add these anthropogenic sources, like, for example, any sort of fossil fuel combustion. And this doesn't mean using electricity. This means coal-fired power plants are adding to this, because when we are burning fossil fuels, whether it's in a car, whether it's in a coal-fired power plant, whether it's for industry, that is adding atmospheric nitrogen oxides. Now, one of the natural impacts of this, or environmental impacts, it is a major contributor to acid precipitation, and it will convert to nitrogen oxides will convert to nitric acid, which is HNO3. But basically you should remember that any nitrogen, the acid that's associated with it, again, is nitric acid, HNO3. And in humans, it can be a respiratory irritant, and respiratory irritant doesn't just mean it will affect the lungs. It can affect, your nasal passages. It can affect your trachea. Anything that is associated with your respiratory system can be impacted from nitrogen oxides. Tropospheric ozone. So we have stratospheric ozone, and that's the good stuff. But when we have it down in the troposphere, it is a bad thing. So this is the second one. This is the O. It is a secondary pollutant. It's formed by sunlight and water that's reacting with VOCs, NOx, and oxygen. Now, we have a special video that's dedicated just to the tropospheric ozone formation, so I'm not really going to go into a lot of the chemistry. However, some of the sources you see, fossil fuel combustion and fossil fuel combustion. I told you also it's reacting with other components, so we'll be talking more about that in the future. But some of the impacts for humans: asthma, bronchitis, emphysema. It is a respiratory irritant, and we can damage plants. And the reason that this ozone is damaging plants is because the ozone gets into the stomata, and the stomata are the little pores on the underside of the leaf that allow the gas exchange, and ozone can get in there and oxidize the tissues. So basically it's damaging the tissues from the inside out. So the plant damage, the reason we have a human impact, if we're impacting agricultural crops, if we're impacting regular like trees outside, that would just be an environmental impact. But both of the agricultural and environmental plants are impacted because of this oxidation. And finally, ozone is a greenhouse gas, and it will absorb infrared radiation or heat energy from the sun as it hits the earth, and it can increase the temperatures at the Earth's surface. Now, sulfur dioxide is obtained naturally from volcanic eruptions, is a major contributor. That is the major natural source, but we also can obtain sulfur dioxide from forest fires. Whenever there is a sulfur containing product and it catches fire, you're releasing sulfur dioxide into the atmosphere. And a anthropogenic source, like most of the other ones, like the same with the same that it was for nitrogen oxides, you're getting sulfur dioxide from combustion of fossil fuels. Okay, driving a car, burning gasoline in an internal combustion engine, generating coal-fired and coal-fired power plants are really bad, especially when you're considering the sulfur content of the coal, and that's why we talked about the sulfur content of the coal in the last unit. But some of the impacts is it can cause leaf damage and plant tissue damage, and this could be, technically it could be environmental, but it could also be a human impact if it's damaging agricultural crops. But for humans, again, sulfur dioxide is an irritant. One other thing that I did not mention is sulfur dioxide can also contribute to acid precipitation, and again, acid rain gets its own video, so we'll be addressing this a little bit more in detail in the future. Carbon monoxide, it's naturally formed during the incomplete combustion of organic matter. So anytime you're burning something, you're releasing carbon dioxide. Now it happens in internal combustion engines. It happens a lot of times if there's ever an issue and people are talking about having a generator. They say don't run the generator in your house, because as you're burning the fuel to power the generator, you are releasing carbon monoxide. And if you release carbon monoxide in a closed environment, it's really, really, really dangerous. So the way that carbon dioxide reacts is it basically binds to hemoglobin in our blood, and hemoglobin is the protein that brings oxygen to our cells. So oxygen normally binds to hemoglobin, but carbon dioxide can also bind to hemoglobin, and it does it more efficiently. So the carbon dioxide is held onto that hemoglobin. That means the hemoglobin can't deliver the oxygen. That means you suffocate. And it's odorless carbon monoxide. That's why we have that's why we have carbon monoxide detectors in our apartments. But you want to make sure that that you're generating, if you're ever in an area where carbon monoxide could be generated, you're outdoors, so you have so you don't have as much of a chance of getting the carbon monoxide intoxication. So it can come from vehicle exhaust or other combustion, and it's really dangerous indoors. So if people are burning kerosene, if people are burning manure, charcoal indoors, you can release a lot of carbon monoxide if you do not have adequate circulation. So some areas in a home that could be danger zones for carbon monoxide: a chimney, fireplace, a generator. Never ever ever run a generator or a grill in a closed space. Another one you never want to run in a closed space is a car. Like, open your garage door when you're running your car. A room heater, especially if it's a gas powered room heater, can release carbon monoxide. Your cooking appliances can release carbon monoxide. A fireplace, heating equipment, your hot water heater or your boiler can also release carbon monoxide. So in these areas in your home, it is very important to have adequate circulation so you're not having a buildup of carbon monoxide. And if you do have these areas, it's a good idea to also get a carbon monoxide detector. I literally just today, the day I'm recording this video, I saw something on the news about somebody who got carbon monoxide poisoning outside on a boat because they were sitting by the boat motor going out on a lake, and the girl jumped in the water and she was already like intoxicated from the carbon monoxide, just thought it was from the sun. She jumped in the water, she never came out. She basically like passed out and drowned from drowning, but from carbon monoxide poisoning. Okay, lead is found naturally, it's found in rocks, but anthropogenically it was found in gasoline until about 1996. It's found in old paints, especially old rooms. There could be lead paint in, like, if you live in an old apartment building, if you live in like old schools, old industrial buildings have it, but also lead pipes. So a lot of cities have lead pipes, and this is actually the contamination that happened in Flint, Michigan a few years ago. They had lead pipes that were basically leaching the lead from the pipes, and it was entering the water. What is an impact? An environmental impact and a human impact is it can interfere with the central nervous system. So for animals and for humans, lead poisoning can contribute to developmental and neurological disorders. All right, particulate matter. Particulate matter is just small little particles that can enter our respiratory system. So if you look at a human hair, this is like a diagram represents a human hair cross section. Human hair is 50 micrometers or microns thick. Now, particulate matter, we have two types. We have particulate matter 10, which is 10 microns thick. See, there's 5 of these that can fit in a human hair. So this is too small to be filtered out by the respiratory tract. We have hairs in our noses. And if these particles are smaller than the diameter of a hair, it's hard for this stuff to be pulled out by your hair or your mucous membranes. It can contribute to respiratory illnesses, but the 10 micron particulate matter is not as bad as the 2.5. The 2.5 can get way into your respiratory system. It can get lodged into the cells in your lungs, and it can cause severe respiratory illnesses and lead to cancer. They lodge deeply in your respiratory tract because they are so small, and because of their size, and they can really interfere, they are usually more toxic. So some of the sources, definitely combustion of fossil fuels and biomass, from road dust, when there's construction, rock crushing, and then naturally they can come from volcanoes, fires, dust storms. Impacts, obviously respiratory illnesses, and if the particulate matter is thick enough, it can block photosynthesis because it's blocking the sunlight. Okay, so some other pollutants that are not mentioned in the criteria air pollutant list is we have volatile organic compounds, and these are a bunch of like chemically. They have a very chemical smell. We have cleaning supplies, we have paint, we have the carpet, the squishy part on the back of carpeting, we have air fresheners, we have glues and markers. All of these are anthropogenic sources. Now also, we can have natural sources of volatile organic compounds, and this is naturally, but plants, especially plants that have a very strong odor, like evergreen trees. If you take the needles of a pine tree, you smell them, it has that very distinct smell. This is a volatile organic compound. And they're called volatile organic because volatile means that they're easily vaporized. They can easily become a gas. And they're organic because they contain carbon and hydrogen. Okay, and another one, and this is a pretty toxic one, is mercury. And mercury is released through the combustion of coal, particularly coal, but also through petroleum. So when we burn coal, we're releasing mercury. That mercury will eventually make its way into the atmosphere, and it will be attracted to the water molecules. And then the water will fall, and the mercury can enter the organic materials of the organisms, and especially it can enter forests and aquatic ecosystems. When it's in the aquatic form, in water, it can form what is called methylmercury. And then methylmercury, you don't have to know the formula for it, but methylmercury can build up and accumulate in an organism's tissues. So larger organisms, larger predatory animals will have more mercury built up in their bodies. And one of the major impacts is it affects the central nervous system. It can also affect child's mental development. And one of the things that doctors recommend is that you don't eat large predatory fish like tuna, especially if you're pregnant. Because look at how big this tuna is. I don't know if you knew that, but this is actually, tuna can get bigger than this as well. So that's larger than a human. And think about all the smaller fish that this tuna had to eat. This tuna is accumulating so many pollutants, and also it's accumulating a lot of mercury. So nutritionists have recommended that pregnant women do not eat as much tuna because there can be a buildup of tuna and it can affect the child development, especially when you're pregnant. Okay, another pollutant, carbon dioxide, and this is kind of a review. This is just like showing the different reservoirs and sinks. There's been natural movement between the ocean and the atmosphere, and between biotic life and the atmosphere. And this has been relatively unchanged for millennia. However, you add the additional combustion of fossil fuels, and we have, even though this doesn't seem like a big number, this is enough to impact and offset the global carbon cycle. So we have the ocean is the largest carbon sink, the atmosphere is a carbon reservoir, and vegetation and soil is also a carbon reservoir. How are we impacting this? We're combusting fossil fuels, and we're taking ancient carbon that's been stored away for millions of years in the form of fossil fuels, and we are combusting that, releasing carbon dioxide into the atmosphere. Graphically speaking, you've seen this graph before, but this is CO2 at the Mauna Loa Observatory, and it's been steadily increasing over the last 50 years. And we have observed this over the last 50 years. And again, there are peaks and valleys every single year, because in the spring, the value will go down because photosynthesis is occurring, and then in the fall and the winter, the value will rise because the plants go dormant. More carbon dioxide is being added to the atmosphere. All right, so the last thing I want to mention is we have primary versus secondary air pollutants. We will talk about all of these, but a primary pollutant is basically has one source. You can pinpoint exactly where it comes from. It can be natural, or it can be anthropogenic. Now the examples are NOx, sulfur dioxide, carbon monoxide, carbon dioxide, lead, particulate matter, volatile organic compounds, mercury. Secondary pollutants has gone through some sort of transformation. So it's going to have sunlight, water, oxygen, something else present that's going to be reacting and forming this other pollutant. It's often going to form in the daylight hours because you got that extra energy from the sun, but also it's going to have water attached to it. So other examples that we're going to discuss, especially ozone, sulfuric acid, nitric acid. This is peroxide and PANS. Now PANS shows up, I don't even know what it stands for, I have to look that up. I don't remember what it stands for, but these are secondary pollutants. The big ones, ozone and acid precipitation, are the ones that you really need to know, and we will be discussing because they get their own video. So for your FRQ practice, I would like you to look at this beautiful graph that I made. We have the flame temperature of coal, and we have NOx formation. So the Environmental Protection Agency, or the EPA scientists, performed an experiment where coal was burned in different chambers at varying temperatures to see how temperature impacts the amount of NOx produced by coal combustion. So I want you to explain how the results of this experiment would be different if natural gas were used instead of coal. So take this opportunity, formulate a response. I thank you for your attention. I will see you soon.